Hi everybody, in this video we're getting into the last type of transformation of a sine and cosine curve, which is the phase shift. Before we get to the notes for that, which are on page 20 of your student note packet, I want to do a couple of examples on page 24 and 25 from the up and down in radians handout. I just want to show you guys some of these examples so you know what I'm looking for on those homework pages. So don't forget to do this handout as well. We're on page 24 here. So the first example at the very top, we want to go up by pi over 2. And this is something that we've been doing as we've been scaling the x-axis so far without phase shifts. And so we're just going to be counting by pi over 2, starting at 0, because that's the number that I've given. So 0 plus pi over 2, that's another pi over 2. And then add another pi over 2, that's 2 pi over 2. And then we get 3 pi's over 2, 4 pi's over 2, simplifies to 2 pi, 5 pi's over 2, 6 pi's over 2, 7 pi's over 2, and then finally the last space here is 8 pi's over 2, which is 4 pi. So simplified answers on a test, if I'm having you guys graph and you have to label all the key points along the x-axis, you want to make sure everything is simplified. Okay, somewhere in the middle, like right in the middle here, we want to go up by pi over 8. So again, I'm just going to start at 0 here, and I'm going to count by pi over 8. So 0 plus pi over 8, that's pi over 8. 2 pi over 8. 3 pi's over 8. 4 pi's over 8. 5 pi's over 8. 6 pi's over 8. 7 pi's over 8. 8 pi's over 8. So we're simplifying. If you guys need to write the first fraction and then simplify, please do that. Make sure that you guys are getting that. You get a point for every label you include on the x-axis that is correct on the test. So just make sure you guys are counting correctly there. All right, last example on the back, kind of in the middle. We're going to go up and down by pi over 3, but this time we're not starting at 0. I don't have a 0 in that space, so we can't assume that that's going to be 0. We're going to start from the middle at negative 5 pi over 12. So this is where it gets a little bit more complicated. We need to find a common denominator here so that I can start adding and subtracting by pi over 3. So here's the trick for these types of problems. Going this direction, we're going to add pi over 3. Going this direction to get backwards, we need to subtract pi over 3. Now, pi over 3 and negative 5 pi over 12, they don't have common denominators, so I'm going to find a common denominator here. If I want to add pi over 3, I'm going to multiply the top and the bottom by 4 in order to get that common denominator. So in this case, we're going to be adding 4 pi over 12 every time we go up. So here we go. Let's do it. Negative 5 pi over 12 plus 4 pi over 12, that's just negative pi over 12. And then I'm going to add another 4 pi over 12 to get me to 3 pi over 12. But this time I've got to simplify. That's pi over 4. Okay, add another 4 pi over 12. That gets us to 7 pi's over 12. Add another 4 pi over 12. We're at 11 pi's over 12. And that's as far as we can go to the right. So going backwards from negative 5 pi over 12, I've got to subtract pi over 3 or subtract 4 pi over 12. So if I do that, that'll get us to negative 9 pi's over 12. And I'm going to simplify that. That is negative 3 pi over 4. All right, subtract another 4 pi's over 12. That's going to be negative 13 pi's over 12. Another 4 pi over 12 getting subtracted is negative 17 pi's over 12. And then one more is negative 21 pi's over 12. And we can simplify that one. That's going to be negative 7 pi's over 4. All right, so that's what I'm looking for on pages 24 and 25. You guys are going to finish that up and make sure you include that in your scans. So we're going to move on to page 20. We're going backwards in the student note packet. We're going to take a look at phase shift today. All right, so phase shifts happen. Those are the horizontal translations, so movements left and right. And we can find the values of those phase shifts by looking at the values being added or subtracted to x or theta inside the sine or cosine function. So in a standard equation, you'll see this represented as the variable d, and we just call that the phase or the horizontal shift. All right, this is the final transformation that we're going to be applying to sine and cosine. Then we'll take a look at different examples that include a bunch of different transformations. All right, remember that when we're identifying horizontal shifts, we actually do the opposite of what it would look like on the inside. So if it's minus an angle, we're actually moving to the right. If it's plus an angle, we're actually moving that many degrees or radians to the left. So the same transformation type applies as what we learned in Algebra 2 last year. Okay, so let's graph a couple of these things and then we'll go from there. Let's start with just a cosine curve. If you've got different colors today, that might be a good idea so we can see the differences. But we're going to graph the cosine of theta first, and I've filled out the table already. And then we're just going to go plot the key points, which are the minimums, the maximums, and the sinusoidal axis points. Okay. Cosine. Let's scale this and then we will start graphing. I am going to count by 15 degrees along the x-axis, and then I'm going to put the maximum, which is 1, and the minimum, -1, somewhere kind of at the top and bottom of the graph to kind of fill it out. All right, got my scale done. Again, counted by 15 degrees along the x-axis and counted by 0.25 along the y. We have theta here, which means we're graphing in degrees, so I'm going to scale in degrees here. So cosine, standard cosine curve always starts 0 degrees along the x-axis at its maximum. In this case, our amplitude is 1, so our maximum here is 1. And then every key point, or every sub-interval length, we are going to another key point. So in this case, for a standard cosine curve, our sub-interval length here is 90. So every 90 degrees, we're going to follow the pattern for cosine. So max, axis, min, back to the axis, and then back to its maximum at 360. And then we can repeat. At 450, we're going to come back down and we're going to hit the sinusoidal axis. I'm going to go backwards as well. So at -90, I'm also on the sinusoidal axis. And then I'm just going to sketch my curve. Smooth, continuous curve, no V's. Make sure that you go through the 2 endpoints. This is a periodic function. It repeats over and over and over again. So we want to make sure that we are going past those endpoints to represent that. All right, new color. We're going to be graphing the cosine of theta minus 45 degrees next. So this minus 45 degrees, if we're identifying the correct transformation here, that minus 45 degrees tells us that we're taking our standard cosine curve and we are shifting everything to the right 45 degrees. So I'm going to take each one of those points that we just graphed and I'm going to move those points to the right 45 degrees. So if I start at 0 degrees, where cosine was at its maximum, if I shift that point right 45 degrees, because we counted by 15 degrees along the x-axis, that means I'm going to shift everything right 3 tick marks. This transformed point goes here, right 45 degrees. All right, the sinusoidal axis now, that one's going to sit at 135 degrees. So I'm just shifting all of these points right 45 degrees to get my transformed curve. That last point on the right is all the way to the end. And then I'm going to sketch the curve. All right, so we've literally taken the green cosine curve and just shifted it to the right 45 degrees. The last example here is going to be the cosine of theta plus 60. So if we're going to identify this horizontal transformation, that plus 60 is actually telling us we're moving left 60 degrees. So I need to take every point from my green cosine curve, the parent function, and we're going to shift it left 60 degrees, which means on this scale, we're going left 4 tick marks along the x-axis to get that 60 degrees total. All right, so if I start at the maximum at 0 degrees, if I shift this left 60 degrees, this point is going here. I'm going to do that for every point. I can't fit that far left one because I'm off the graph there. But 90, the point at 90 degrees goes to 30. And I'm going to repeat that for every other point here. And then I'm going to connect the dots. Okay, so this is what all three graphs look like total. We didn't change the amplitudes or the frequencies of any of these. We are just practicing movements left and right. Okay, so on the next page, we've got a couple of examples without phase shifts, and then we'll get into 3 and 4 that do, and then you'll do the homework problems the same way. So number 1, we've got 8 times the cosine of 2/5 x plus 4. We're just going to fill out this table, and then we will graph the curve. So the sinusoidal axis, that vertical shift, remember it's the equation. We're going to graph that. That's the movement up and down. So y is equal to 4 becomes our sinusoidal axis. The amplitude is the number sitting in front of cosine. In this case, it's 8. Our max is going to be 4 plus 8, which is 12. And our min is going to be 4 minus 8 to give us -4. The frequency is on the number on the inside with x or theta. In this case, our frequency here is 2/5. We take the period we find the period by taking 2 pi, which is our standard period, and dividing by the frequency. Our variable is x here, which means that we're going to be graphing in terms of radians. So we need to use 2 pi and not 360. When I do that division, we're going to get 10 pi as our period, divided by 2, which is 5 pi. The subinterval length is always our period divided by 4. So 5 pi over 4, that doesn't simplify. And then our key points. So I'm going to set up the ordered pairs, and then I'll fill in the y values and then go back with the x values. We are graphing cosine, the standard cosine, not reflected here. So remember that the order of key points for cosine is max, axis, min, axis, and then back to the max. So our maximum here is 12. Our axis is 4. Our minimum is -4. Back to the axis at 4, and back to our max at 12. And then I'm going to fill in the first 5 x values. So we don't have a phase shift here, which means our first key point is going to start at 0 radians, and then we're counting by that subinterval. So we're counting by 5 pi over 4. Add another 5 pi over 4, that's going to get us to 10 pi's over 4, or 5 pi over 2. And then 15 pi's over 4, that doesn't simplify. And then we're going to have 20 pi's over 4, which is 5 pi, right? That matches our period. The first 5 key points should get us 1 full cycle, which means we should be ending that last key point at our period when we don't have a phase shift. All right, let's scale the graph and then sketch the curve. All right, so I have put the sinusoidal axis right down the middle of this graph. So when I've got a vertical shift, I always try and make sure that my sinusoidal axis is what's down the middle, and then that'll make sure everything fits. And then I had to scale by 4 on the y-axis, and we're scaling again by that subinterval length, 5 pi over 4, along the x-axis. And we want to make sure we have enough points to include 2 full cycles at least, and we always want to make sure we have at least 1 point to the left of the y-axis. So let's get started. Cosine here is going to start at its maximum, which is 12. And then sinusoidal axis, minimum, axis, maximum, and I'm just going to follow that pattern for all of those values that I marked along the x-axis. And then I'm going to make sure that I go backwards to graph those negative points. And then sketch your curve. Go through the endpoints. Make sure that you don't exceed the minimums or the maximums. And make sure you guys have at least 2 full cycles there. Pause the video, go ahead and give number 2 a try on your own, and then when you're ready, come back to check your work. This is just another review problem, and then we'll get into 3 and 4, which include the phase shifts. Final answer for number 2 looks like this. If you need time to check your work, go ahead and pause the video. We're going to move on to number 3. All right, so for the case of phase shifts, the way that we're going to approach this is by first making sure that the coefficient in front of x or theta is always 1, because that's going to help us identify the correct phase shift and also the correct frequency, but most importantly, the phase shift there. So we have this sine curve, 2 sine of 3x minus pi minus 3. But if we said the phase shift was to the right pi radians, we would be off. So it's kind of like the negative in front of the x on the exponential and logarithmic curves. We want to make sure first that the coefficient of x is always positive 1. So I'm going to start by rewriting this. I'm going to rewrite this equation as 2 times the sine of 3. I'm going to factor the 3 out, right? That's our frequency. But when I factor the 3 out of both of those terms to make sure that the coefficient of x is positive 1, I also have to remember that I need to take the 3 out of the pi as well. So when I rewrite this equation, we should get 2 times the sine of quantity 3, or 3 times the quantity x minus pi over 3, and then minus 3 is our vertical shift there. So the correct phase shift then becomes right pi over 3, not just right pi. So be careful on those. All right, let's start in order. Sinusoidal axis, or that vertical shift, we're going down 3. That would create the horizontal line y is equal to negative 3. Our amplitude is 2. Our max is always found by taking the shift and adding the amplitude. So negative 1 is our max. And then we're going to have negative 3 minus 2 to get our min, which is negative 5. The frequency here is 3. It's the number in front of x or theta. In this case, we're using x as our variable, which means we're going to be in radians. So to get the period, we're going to take 2 pi and we're going to divide by our frequency, which is 3. That doesn't simplify, so we're good there. The subinterval length is then going to be that period, 2 pi over 3 divided by 4. So that's going to get us 2 pi over 12 or pi over 6 as our subinterval length. So we're going to be counting by pi over 6. Now, we've got that phase shift, and the way that I'm going to identify the phase shift in this table is with the correct sign that represents right or left. So we're moving right pi over 3. So I'm going to make sure when I identify that phase shift, that right pi over 3 becomes a positive pi over 3 I'm pulling out. Now, here's the difference in the key points. The only thing that's going to differ from the steps that you guys have been taking in the last couple of homework assignments is going to be where we start the first key point. So our phase shift now becomes the first x value in our set of key points. That's the only difference you have to remember, is that we're going to be starting at the phase shift instead of at 0. Now, before I finish all of those x values, I'm going to go back to what we normally do. So I'm going to think about the order of key points for sine. Sine always starts at its axis and then hits its max, axis, min, and then axis. We're graphing standard sine, no reflections here. And then I'm just going to fill out those y values. So the sinusoidal axis, that's negative 3, negative 1, negative 3, negative 5 is the min, and then we end back at negative 1 for one full cycle there. Sorry, not negative 1, negative 3. And then I'm going to start filling in those x values. Now, again, first x value, always going to start at the phase shift. Up until now, our phase shift has just been 0. We just don't include that in the equation. But we're always going to count by that subinterval length. So we are going to now go up by pi over 6, starting at the phase shift pi over 3. So I need to add pi over 3 plus pi over 6 to get to this x value here, which means we need to find a common denominator. Pi over 3 is the same thing as saying 2 pi over 6. So that next key point is going to be 3 pi over 6. I'm going to write that out, and then I'm going to simplify. That is going to be pi over 2. All right, and then again, we're adding another pi over 6. So this is 4 pi's over 6. I'm showing the work here so you guys can see that. That's actually 2 pi over 3. And then 5 pi over 6 becomes my next x value. That doesn't simplify. And then 6 pi over 6 becomes pi here. And it's okay if you guys want to write the unsimplified fraction and then go back and simplify. It's definitely going to help not make as many mistakes necessarily. All right, we are going to graph everything, which means the first thing I need to do is start with the scale. I am actually going to drop my sinusoidal axis right down the middle first. All right, so that's going to be the line y is equal to -3. So then, and the order is going to become really important with phase shifts. I am going to now drop my x-axis to make that line y is equal to -3. So my x-axis needs to be all the way up here at the top. Okay, here is my biggest suggestion. Before you drop the y-axis, anytime you've got a phase shift, before we drop that y-axis, we're going to scale the x-axis first, because we might not have a y-axis that fits nicely with the way that we have to scale based on the phase shift and the subinterval length. So let's see what happens, and then we'll go from there. So we're scaling by pi over 6, but we're going to start with our phase shift, which is pi over 3. So I'm going to drop my phase shift somewhere over here. I'll call that pi over 3, and then I'm going to count by pi over 6. So that was 3 pi over 6. This is 4 pi over 6. This is 5 pi over 6. This is 6 pi over 6. This is 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6. 12 pi over 6. And then we also have to go backwards because we also want to make sure that we have a point to the left of the y-axis. And because the way that we started with our phase shift, we've only got positive x values right now. So I've got to subtract pi over 6 now. So remember, pi over 3 was 2 pi over 6. So this is a single pi over 6 if I subtract pi over 6. Still not in the negatives. So again, I'm going to subtract another pi over 6, and we've got 0. And then another pi over 6 will get us to the negatives, negative pi over 6, negative 2 pi over 6, and that's all I can fit there. All right, so we're going to be really careful when we go to draw our y-axis. In this case, we have 0. We have a point at 0 that fit nicely with the way we counted and the way we're going to scale. So 0 goes here. That's where our y-axis is going to get drawn. Sometimes your y-axis is not going to fit nicely. Sometimes the y-axis will be just kind of randomly between two grid lines. And that's fine as well when you've got a phase shift there. When we're not starting at 0, we don't necessarily have a really nice point that matches with the value of x being 0. All right, let's sketch this curve. So we are graphing sine, standard sine curve. So we're starting at the phase shift at pi over 3, and sine at pi over 3 always starts on the sinusoidal axis. Let me just mark the values we're counting by along the y-axis here. I'm counting by 1. All right, so at pi over 3, which is our phase shift, that first point, we are going to be on the sinusoidal axis. And then sine is going to go to its max, axis, min, axis, max. And we're going to repeat that for all of these key points here. And then I'm going to go backwards. So from pi over 3, moving to the left, we're going to go down to the minimum at pi over 6. And then axis at 0, maximum at negative pi over 6, and then back to its axis at negative pi over 3. Connect the dots. And that is our final graph with our first phase shift. We're going to do one more together, and then you guys are going to do the homework the same way. All right, for the case of number 4, before we actually get to the graphing of this, I'm going to walk you guys through the graph, but I want you to find all the information first. So fill out the table, take a second, pause the video, and then we'll get to the graph together. But the first thing you're going to want to do is you're going to want to factor out that pi over 4. We want the coefficient of x to be positive 1. So we've got to factor a pi over 4 out of both of the terms on the inside of cosine. And in this case, when we factor out that pi over 4, we get x plus 3 on the inside. So our frequency is pi over 4, and then that phase shift comes from that plus 3 on the inside. So be careful to identify it correctly. So pause the video, fill out the table, and then I'm going to walk you guys through the graph of this. Okay, so here's the table. Our sinusoidal axis shift is y is equal to 10. It's that line, that horizontal line. Amplitude 15, max 25, min negative 5. Frequency is pi over 4. Our period then is 2 pi divided by that, which is 8. It's kind of nice because we get rid of the pi's, so counting along the x-axis is going to be really easy here. Our subinterval length is then 2. Phase shift is negative 3. It's to the left 3. That's where our first key point is going to start then. Now we are graphing the reflection of cosine, which means that our order of key points becomes minimum, axis, maximum, axis, min. So we switch the min and max order on the reflection of cosine, and we're going to go graph this together. So because we've got a phase shift, I'm going to do this in a specific order. The first thing I'm going to do is right down the middle of my graph, I'm going to place what would be the sinusoidal axis. So right down the middle, that is going to become the line y is equal to 10. So next, I'm going to drop my x-axis in a place that would make that line y is equal to 10. I think what we're going to end up having to do here is probably scale by 5. So what would make this y is equal to 10 if I'm scaling by 5 is if I drop my x-axis 2 spaces below that. And then we're going to have to scale by 5 along the y-axis. But I'm not going to graph my y-axis just yet. The first thing I'm going to do is I'm going to scale the x-axis. Because I've got a phase shift, I want to make sure that I have all of the values along the x-axis labeled first, and then I place the y-axis where it belongs. So our phase shift is negative 3. It's kind of nice because that means we're starting in the negatives, which means we won't have to worry about making sure we include a negative. And we're counting by our subinterval length, so we're going up by 2. So that's going to be negative 1, and I'll space this out a little bit more. Let's see. Negative 1, add 2, 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. I'm just going to go till I run out of room. And then I'll go backwards as well if I can fit this in. So negative 5 works there. All right, so once I've got the x-axis fully scaled with all of the key point values, now I'm going to drop my y-axis. Okay, we've got to drop it in the right place. So the y-axis is where x would be 0. Now, x is 0 between negative 1 and 1, and it's going to go right down the middle between negative 1 and 1. So the y-axis actually goes off of a grid line. It's between 2 grid lines there. That's because we have a phase shift that doesn't necessarily work nicely with the sub-interval length and the way we scale the x-axis. So it's always best to drop your y-axis last when you've got a phase shift because sometimes it's not going to work out nicely. If you were to have put that y-axis I don't know, say over here or something like that, you'd lose points. You want to drop it accordingly in the right spot, okay, given the numbers that you have. All right, now I said we're going to scale by 5 along the y-axis, so I'm just going to mark that. That's -5, and then 25 is up here. All right, so I just want to make sure I've got my min and max marked and that sinusoidal axis going through the middle of the graph. Okay, last thing we've got to do is now just sketch the curve. So we're graphing the reflection of cosine starting at our phase shift, which is -3. So the reflection of cosine always starts at its minimum. We're starting there at the phase shift, and then I'm going to follow the order of key points. So then we're at axis, max, axis, min, and then I will continue that pattern. I'm also going to go backwards. So at -5, we're going to be sitting on the sinusoidal axis. I'm just going to sketch the curve there. Go through those endpoints. Okay, and we see here in this space, we don't have a point sitting on the y-axis, which is why that y-axis is kind of just floating in there. We didn't have a key point along the x-axis at 0 radians, which is why we skip that y-axis. You don't always have a point on the y-axis. That's one of the common mistakes I see when I grade homework and tests for this unit. So just be careful about that and the phase shift. Email me if you've got questions. You guys are going to be filling out the tables for your homework assignment on page 22 and 23. And then you could probably fit all of the graphs on that graphing area at the bottom of page 23 if you graph small enough. So make sure you guys include at least 2 cycles and 1 negative key point.